In this video, we are going to discuss equilibrium of planar force system. So let's solve a problem. A cylinder of mass 100 kg is resting on a smooth surface which is inclined to the horizontal as shown in figure. Determine the reaction at contact points P and Q. To solve this problem, we need to take the freeboard diagram of the cylinder. So let us take the freeboard diagram of the cylinder. With the cylinder, now we have a surface which is tangential to the cylinder. So let us draw a tangent here, and now let us draw a force or reaction which acts exactly perpendicular to the surface. So let us say this is perpendicular and it passes through point P. So this is the reaction force acting at point P. Then there is one more force, reaction force acting on the other side. So this is the tangent surface, and exactly perpendicular we have to take the reaction force. So this reaction force acts at point Q and this acts upward as shown like this. Now let us call the reaction force on the left hand side as R1 and the reaction force on the right hand side as R2. Now these are the two forces acting on this, and there is a third force which acts exactly vertical, which is nothing but the weight of the cylinder. So now let us draw that weight of the cylinder which acts through the center of the cylinder. So let us say the center of the cylinder is somewhere here, so it acts through the center of the cylinder. So this is actually given as 100 kg. Now we can see that there is only mass, but we need a weight. So this is to be written as 100 multiplied by 9.81 Newton. That is the vertical force, which is nothing but the weight of the cylinder. Now let us decide what are the angles R1 and R2 make with this vertical force. On the right hand side diagram here, we have the slope triangle, and let's say this angle is some theta or theta 1. Now this theta 1 we can write in this slope triangle. Opposite side of this theta 1 is 3, adjacent side is 4, and so we can write for tan theta 1 equal to opposite is 3 and adjacent is 4, and tan inverse 3 by 4 will be equal to, so this will be 36.87. so we can write theta 1 equal to 36.87 degrees. So let us decide what are the angles here. Now this angle here is, let us say we will draw one horizontal here, and so this angle here is 36.87. now if we draw a vertical, let's try to draw a vertical at the point P. So I am drawing a vertical here. Obviously this angle is 90 minus 36.87, but as this R1 makes exactly 90 degrees with this surface incline, so that means this angle will be 36.87. like this we can find out the angle between R1 and this vertical, whereas why we are trying to find out the angle with the vertical, because the weight is acting vertically downward. So this is 36.87. Similarly, let us find out what is the angle of the other reaction force R2 with the vertical. So I am going to draw another vertical at point Q here, and let us say, let's take a horizontal line, and as we know this angle here is 60 degrees, so this is 90, and so this will be 30, and because this total angle here is 90 degrees, so if we subtract 30 degrees on that, it will be 60 degrees. So R2 makes an angle of 60 degrees with the vertical. R1 makes an angle of 36.87 degrees with the vertical. Now to solve this problem, we can construct a force triangle. Now let us draw this force triangle. There are three forces. One is 100 into 9.81, that is 981 Newton. Then R1 and R2. So for that, let us try to draw first a vertical line. So I am taking a vertical here, 981 Newton, and let us draw a force which is equal to, which is in the direction of R1. So let us say I will take exactly parallel to that line of action of the force. Now we can see this is the direction of R1. We will draw like that and leave it, and then we'll take one more force, that is R2, which is parallel to this line of action here. So as we know, that angle is 30 degrees with the horizontal, so or 60 degrees with the vertical. Now from the other end of this weight, so we are drawing this. Now we can see that this is R1 and this is R2. Now let's try to find out the write the angles here. So as we know, R1 is making an angle of 36.87 with the vertical, so that means this angle is 36.87 degrees, and the angle between R2 and the vertical is 60 degrees, so this is 60, and let's call this angle as the angle between R1 and R2 as some alpha. So we can write, because in the triangle the total angles must be equal to 180 degrees. Let's write 36.87 plus 60 plus alpha equal to 180 degrees. So from this we can calculate alpha equal to 83.13. Let me write here 83.13 degrees. Now once we calculated the three angles, now because the system is in equilibrium, we can apply Lami's theorem to find out the unknown forces. What is that Lami's theorem? Lami's theorem says that if three forces are in equilibrium and they are forming a triangle, so we can write the sine rule. So we can write 981 divided by sine alpha. Alpha is now 83.13, so that's 83.13 degrees is equal to R1 divided by sine. So R1 opposite angle is 60, so that will be sine 60 equal to R2 divided by, for R2 the opposite angle is 36.87, so sine 36.87 degrees. Now in these two unknowns are there, so R1 and R2, so we can calculate easily what is R1 and R2. So first let us take R1. R1 equal to, if we take the first set of equation, so this will be 981 by sine 83.13 multiplied by sine 60 is equal to 855.71 Newton. Similarly, you can calculate R2 using the second set, this equation, this quantity and the first quantity. So R2 will be equal to 981 divided by sine 83.13 multiplied by sine 36.87 is equal to 592.86 Newton. So this is how we can solve the unknown reactions that are offered by or applied by the contact surface at point P and point Q.